Well, it's another exciting night of word problems. You will learn to love these. Maybe. Our first step is to read the problem. So let's take a look at a problem. An office building has two elevators. One elevator starts out on the 4th floor, 35 feet above the ground, and is descending at a rate of 2.2 feet per second. The other elevator starts out at ground level and is rising at a rate of 1.7 feet per second. Write a system of equations to represent this situation. Okay, when you read this problem, there's certain things that you should start making inferences, and right now we're only doing linear systems, but long term you're going to learn a lot of different kinds of systems. So when we read this and we see a rate of per second, that should make you think linear function, a constant rate of change, 35 feet above the ground, a starting point, right? So you want to start connecting the math you learned first quarter when you're reading these higher level problems, and that will continue all the way through algebra. So there's my sidebar. Let's go back to the problem. Okay, I'm going to take this problem and I'm going to put it on a graphic organizer so that it looks like your note sheets. Okay, so first let's get rid of that one and put up the graphic organizer. Okay, so we still have the problem up here as we start to look for information. First thing we have to do is define variables. At this point, we know we're doing linear systems. We're probably looking for two variables. I'm going to go with x and y. You can pick what you want. I want x and y. I like it. Okay? So I've got my x and my y. Now, it says write a system of equations. It doesn't ask us any question to solve. So we don't have a clue there on what the variables are going to define. So this is where you have to read the problem, and I'm going to give you a second to read it a couple times and think of what you would define the variables as. Have you made a decision? I'm going to make x time. We don't know how long the elevators are traveling. So if you ask me, at what height is the first elevator, I'm going to say, after how long? 0 seconds, it's at 35 feet. 10 seconds, it's at a different height. So we're going to make x time, and y is going to be the height. I could ask, what's the height of the elevator? We don't know either one of those pieces of information, and remember, the variables are always the things we don't know. The tricky part is being able to read the problem and decide what you don't know. It takes a lot of making inferences often. Now, like I said before, we want to connect everything back to what we've already learned. Think about all the problems we did in linear functions with x time on the x-axis and height on the y-axis, and you'll see a lot more of that after Christmas too. So you want to start, when you see these things reoccurring and you recognize that, it makes the math easier. Now we just have to write a system. So let's make our first equation is going to be for elevator number 1. Okay, the height of elevator number 1 equals the initial height. It starts out at 35 feet above the ground, plus the rate of change, 2.2 feet per second, times how many seconds it traveled. So given this equation, I could tell you the height of that elevator for any given time, or I could tell you after how many seconds how high the elevator was. Okay, so that's your first equation revolving around elevator number 1. Now let's take a look at elevator number 2. Again, the height of elevator number 2 is 0. It starts out at ground level, so it's 0 feet above the ground, plus a rate of change of 1.7 times the time. Right? So this elevator is traveling a lot slower, and this elevator is not only traveling faster, but it starts out a lot higher. So if if it was Willy Wonka and these elevators are going to go straight up forever and never stop and come back down, would they ever catch each other? Something to think about. Okay, that's all we have to do for that problem. Let's move on to the next one. The perimeter of a rectangle. Oh, geometry problem. The perimeter of a rectangle, when you see a shape, I want you to immediately think, make a sketch of the shape. Here, look, there's a big one, a big picture frame representing the rectangle. Anyway, back to the problem. The perimeter of a rectangle is 48 inches. The length is 6 inches greater than the width. Define the variables and write equations to represent this situation. Again, we don't have them asking us for anything. Makes it more difficult to define the variables, but it's a great opportunity for you to practice defining variables. So let's get rid of this big one and take a look at the problem and the graphic organizer, because I want you to really get in a habit of that. The perimeter of a rectangle is 48 inches. The length is 6 inches greater than the width. Define the variables and write the equations to represent this situation. Okay, let's start defining some variables, shall we? Again, I make mine X and Y. I am a creature of habit and I just like them. So, I'm also going to make a little sketch over here because it helps me, even now, when I have to work these problems out. I've got my little rectangle here. It tells me the length is 6 inches greater than the width. I need X to be something. I'm going to make X the width, and I'm going to make Y the length. They're two attributes. I know the perimeter, but I don't know the width or the length. So I'm making X the width and Y the length. Okay? Now we have to write some equations. We're going to look at the information they gave us. First of all, the perimeter is 48 inches. Can you write an equation from that? If the length is Y up on this side, it's in a rectangle, it's Y down there by definition, and this side, both sides have to be X, right? So the width is X plus, or the perimeter, I'm sorry. The perimeter is X plus Y plus X plus Y. So you could write it out like this, which I think is kind of long and troublesome, or I could say the perimeter is going to be 2x plus 2y's, right? It just looks easier. So I know that 2x plus 2y equals the perimeter. 48. They told me what the perimeter was, right? Okay. Now, our next fact that we have to write our second equation, I'm doing this one in pink and purple, it's girly. Nice and girly today. Okay, 48 inches. Oh, we did that, I'm sorry. A little confusion. 6 inches greater than the width. The length is 6 inches greater than the width. So the length is longer. So if I had the width, what would I have to do to the length or the width to make them equal? If the length is 6 inches greater than the width. We know the length is bigger, so if I add the 6 to the width, there's my system. Now, that's the way my brain thinks. Everybody's brain doesn't work the same. Let's look at an alternate method. If I have X and I have Y, the length and the width, and I say the length is 6 inches greater than the width, your brain might think, well then, if the length is bigger and I take 6 away, that would give me the width. Either equation is fine. And you gotta understand that they're the same equation, because what would happen to this equation if I add 6 to both sides? Right? It becomes that. See, they're the same equation. They're just manipulated differently. Doesn't matter which form they're in, whichever one works for you. Now, unlike the first problem, you could take this and solve it, right? See how you could solve a substitution? I'm not going to have you solve them for homework tonight, though. I just want you to make sure you have your notes when you come to class tomorrow, because we're working on word problems, and I want you to really be engaged in the conversation and start to understand these fabulous word problems. So, that's it for tonight. Have a good night, and I will see you ready to learn tomorrow.